would want that to happen in this case is beyond me. It doesn't sound like good design. But technically it's legal. Right? So I'd like to go back and re-answer the original question. What effect does making these delete have on the derived class? It basically means you can't let the compiler generate those for the derived because it won't be able to. It won't be able to call the base class versions. Okay? Yes? Why were some of the solutions on the previous slide not optimum? See me after class and I'll go through it. Okay, it's well documented. It's old stuff. So I want to try to fit the new stuff in. Okay. So here is an old C++ class hierarchy. So we got a base class and we got F and G, which are declared virtual. G is also const. We have a non-virtual function H. Then we have a derived class. In old C++, there's a lot of potential confusion here, or just outright errors. So if someone is just looking at this code, let's say this is in a different module, so I'm not really seeing that. If you just looked at this line, how do you know if F is virtual or not here? You don't. You have to know if it's virtual or not in the base. So that's confusing. Is this G meant to override base's G? Let's say you even knew that base has a G, but you're not really thinking about the declaration. So was this meant to override this or not?
Well, it won't.
It won't, but you don't know what was in the mind of the person who wrote that line. It's not clear what the intention was. It's confusing and ambiguous in some sense. Not to the compiler. It's ambiguous to somebody trying to read the code. What does this do? Does this override base's H? No. Because to override, it has to be a virtual function. That's the definition of the word override. So what's...
On the other hand, if you have a variable of type derived, then it will use the H in the derived class. If you have a variable of type base, it will use the H in the base. So
there's all sorts of...
situation where you think you're overriding,
Okay.
but you're really not.
So the question is about the behavior of having these two H's. I don't want to consider that because it's horrible design. It's a mistake. Don't do it. End of story. This is a mistake.
Sure.
There's very limited number of use cases where redefining or hiding a name is a good idea. It's the majority of the time this happens in a code base. It's a mistake. Okay. So again, you can't look at this and know if the person who wrote this intended this to be an override or not. Because the person who wrote it might have expected it to have been virtual. Or maybe they didn't even understand that it has to be virtual to be overridden. So those are all the mistakes. Now let's see how all those issues are solved. So in new C++, there's a couple of new keywords, final and override. You can declare a member function final. That means it becomes a compile error to try to override it or redefine it. You get a compiler error here. Good. No one should have ever done this. Now, if your intention is to override, you just say so. I want this to be an override. For this to be an override, the base class counterpart must exist and be virtual. And if it doesn't compile. Same thing here. So this is correct. Presumably, we are trying to actually override this virtual F, so that's the right way to do it. This will generate a compile error, and you'll go either, oh, I didn't mean to put the const there, or, oh, I meant to put a const here. One of those two, probably, is going to be what you say after oh. And you fix it. And then this just doesn't compile. Now, the punchline here, final and override have not been existing keywords. The Standards Committee hates to create new keywords because every new keyword that's created and injected in potentially breaks code. Somebody could have had a variable called final. That's not hard to imagine. Or override. These are contextual keywords. They only have the behavior they have when you use them exactly where you're seeing them. And if you use them as the name of a variable, fine. you can still have an int final inside of H. The question is, you have to remember that there's an equals default equals delete. I would suggest when you're writing a class, you use each of them to their fullest capacity. And then there's no more having to remember anything. All four of these, the equals default, the equals delete, the final, the override, they're meant to clarify intention and let the compiler enforce the intention and avoid silent weeks of debugging. Yeah. Maybe not so silent. Weeks of debugging. All right. So I love the fact they're contextual keywords. That's like an awesome invention. Question?
Can you specify final derived class?
You mean like that? The question was, can you do that? Okay? Yes, a class can be declared final. That's how you do it. It is also a contextual keyword, and it doesn't break any legacy code. Yeah.
I remember the containers in the old C library, C++ library, like Vector, for example, do not have virtual
Correct.
constructors.
Right?
So those have to be final classes, right? Because I've done this, and
They don't have to be. Okay, the question is, what about stuff like STL containers that are not polymorphic? They don't have a virtual destructor. So the reason they don't have a virtual destructor is there's a performance cost for that.
Sure.
And if you really want to employ a vector, most people do it through containment. Is it legal to inherit from a vector? Sure, but you better not try to use a mixture of vectors and super vectors polymorphically, because then you'll be in deep you know what. So the language is permissive, right? It lets you do that if you really want to, but it's not designed to support polymorphic use of vector as a base class, that's all. Okay? So final classes. In old C++, constructors could not leverage other constructors of the same class. If you learn Java and you see how Java constructors just call each other, you go, why can't I do that in C++? Well, now you can. In C++ 11, a constructor can call another constructor. So let's say we're trying to model flux capacitors. So here's 4 different constructors for flux capacitor. And the one that's really the workhorse, well, actually, in this case, there isn't any. I'm sorry, this is the example of old C++. So everyone duplicates effort, which means you now have real potential for error here. If you leave out some of these steps in any one of these constructors, you'll be in trouble. And in fact, there's a logic error here. I'll get you started, see if anybody can spot the logic error. And it's not going to be diagnosed by the compiler, most likely. So the default constructor sets capacity and ID. ID is driven off of a static counter, basically, that you use to keep a rolling index number for your flux capacitors. Because when they're going back and forth in time, you can get quite a few of them all. You definitely need a multi-threading environment to really make use of that. The one that takes a double will will initialize everything. One that takes a complex, etc. Anything about the bug here?
well, where do you initialize
Not flux capacitor, but there is something uninitialized.
Where do you initialize
Capacity, that's the bug. This constructor does not initialize capacity. It's got garbage. Okay, so that's the old scenario. In 11, in new C++, this is the workhorse. The one that takes the complex actually does all the work. So it validates, it sets the ID to the next available number, it initializes the capacity. So now, it's a lot harder to forget to set the capacity. As soon as these other constructors are coded to call this one, or either directly or indirectly, that issue goes away. The default constructor calls the one that takes a double. The one that takes a double calls the one that takes a complex. The one that takes complex does all the work. And the copy constructor also calls the one that takes the complex. So there's less chance of failing to initialize. However, there's another subtle problem this does introduce, and there's no silver bullet for this. Now, there's a performance hit here. Anybody spot it?
Well, you have to call two functions.
That's not it. In fact, all of these are inline, and it's as if you just called one function. Yeah. Very good. You're calling validate when you don't need to in some cases. All right. Certainly when you default construct, you don't need to validate, right? So if you're willing to pay the price of calling validate a little too many times, great. So now you have to make a decision what's more important.
But you can always, excuse me, if you object to the overhead, you can always write your own personal default constructor in that case instead of.
Absolutely. Okay. You can.
Yeah.
So the question is, if you don't want the overhead, you can start manually taking care. Of course, but now you have to consider what the performance issues are. So it's not a silver bullet. It's not like an instant solution to all problems. It's just one more tool in the arsenal. Yes.
Is the call to
Sorry.
another constructor first in the list of initializations?
Question is the call to another constructor. It'll pretty much follow the usual order. Okay. So because this is basically acts like a base initializer. The calling sequence is first. If you're default constructing as a user, the first call will be to the default constructor. The first thing that's is invoke this constructor. Then it's going to come back. It's then going to do some other initialization because that's how C++ works. And then it's going to go in here and do what's in the braces.
So you could make like a call for a base class or data member before you just call the other constructor.
So the question is, can you control the order of things? No, but you can specify what's going to happen for each of them. So remember, the order is very fixed. The order of initialization is absolutely fixed by the language. It always does base initializers first in the order of their declaration. Then it does member initializers in the order of their declaration. Then it does members. I mean, data members. So, then it does what's in the braces. So, and the destructors are the reverse of that. So the order of everything remains the same. So all this really adds is the ability to reuse the code in one of the other constructors than the one that's initially called. That's all. Okay. So now let's look at data. In old C++, the only types of data members that you could initialize in class, in the braces of the class definition, in here, the only things you can initialize are const, static, integral data members. Basically, and their relatives. Bools, shorts, longs, ints, unsigned, unsigned longs.
So you can do
Enums were constants.
I mean, a variable that is an enum type.
An enum type, okay. But that's an integral type.
Yeah.
Okay, so it's in the family of integral types. And my theory, I don't know this for sure, but it makes sense. The reason that the language decided to allow that is so you could have an initialized